Hello everyone, my name is Vinay Kumar. A very good morning, good afternoon, and good evening to everyone, the person who are joining across the world. My name is Vinay Kumar, and today we are going to talk about Kafka and event-driven architecture. And thank you very much for the team who gave me the opportunity to talk on APAC Oracle User Group. So thank you very much. I'll start. A brief about myself. Uh, I'm an Oracle ace from 2014. I'm currently working as a global integration architect, leading the application and the integration architecture in one of the largest insurance companies. I have also authored a book on Oracle Web Center Portal 12c, which is also available across on Amazon or a press publisher. I'm a frequent blogger, and I'm also used to write some articles on cloud and Oracle and open source technologies. Moving on. As part of the Oracle ACE program, I have to say a few words about the Oracle ACE program. So they are 3 tiers, and I'm an Oracle ACE from 2014, as I already mentioned. There are 3 tiers. So if some of you who is already interested to be in Oracle ACE, please look at the link provided here, and you can be an Oracle ACE. The starting point is Oracle ACE Associate, and then Oracle ACE, and then the Oracle ACE Directors. So please go through, and if you have any questions, yeah, please let me know. So what's the agenda? In agenda, I mean, I'm really going to talk about how how the evolution really happened. What are the interaction styles from the past, from the time we have start building the software systems? How do we try to implement the SOA approach? How the traditional SOA approach? How event-driven architecture really is? What are the challenges which SOA cannot fulfill, and why we really need event-driven architecture? Then I will also going to talk about event with microservices, how we can do the event streaming with Event Hub, integration with legacy, what is Kafka. I will also go about some of the internals of the Kafka, and then async APIs. That's some of the documentation about events. So when we talk about communication style, I mean, if we go back 15 or 20 years ago, we have mainly two type of interaction. Initially, everything was request and response. Everything is working on the model view controller MVC based architecture, and whatever you make a request, and then you wait for the response, and that's what you normally say as a synchronous system. But normally, if you say the communication style in any system softwares, we have time driven, we have request driven, and the event driven. In time driven, you just configure the system in that way that some operation or something would happen on a specific time. Request driven, as mentioned by, it's already client server, so client will request something to the server will process the request, and then give back the response back to the client. Event driven is something like an open ended, so you something has happened, and that's the message passed to the interested parties, and that's we call something as event driven. We will go through about in detail in the next slides. So let's talk about the time driven. What exactly the time driven? You have a store system, and you need to check the inventory in every 30 minutes. And to do that, you make a batch operation or some sort of a scheduler which runs every 30 minutes to check how the inventory of the storage look like, and then you update into the user interface. Pretty straightforward. I mean, still we do have use cases. We still do polling as of now, and still in nowadays, even in the modern architecture as well. So that still makes sense. Request driven, it's a traditional approach, and that's still valid for a lot of application. As of now, we have a server, we have a client made a request to the server process that request and give back the response to the client, and that's what we normally call a synchronous service. Event driven architecture, I mean, whenever we talk about the distributed architecture or distributed application, which is spread out globally, and we have distributed systems, multiple servers, multiple machines, and there event driven is really help. And if you say in a store, I mean, let's took an example of the previous example which we have used for the store. We want to say inventory is updated, and imagine we have to update our websites, or we have to update or we have to trigger our new order management system, that inventory is low. Let's buy some new products, or let's update the inventory. Or we say inventory is updated, and then depending on the marketing department will have to do something. So inventory is updated, inventory is low, inventory is full, and these we call as simple as events. And then interested parties or the interested departments can do according to what they have to do with this information, and that's what we call normally as event driven system. So if you see, we have generators, which is like a producer of the events. We have a distribution layer, which we normally call as event hub, and these are the multiple consumers. So every consumer can subscribe to the respective events, and once they got that event, and then they can perform the respective operation, and that's what we call an event driven architecture. Event notification, like this is the best example. A girl throws a stone in the lake, and that's an event. And once you throw and then you forget, so fire and forget, and that's what you call an event. You will not wait for the response, what would happen after you process that event, and that's you call as event notification. Events, as if you go to the definition, anything is happened or didn't happen, a change in the state. An event is always named in the past tense and is immutable, so something which is already done you cannot really change. And condition that triggers a notification, that's mainly you define as an event. So if we go to the enterprise examples, a customer address has changed. Do some our finance department need to do something? Please do. Inventory updated, sales order created, purchase order created, and respective teams whosoever is interested in these events, they can perform the action on top of that. Characteristics of the events. Events are always a real time. So anything real time events that as they happen at the producers, it's always on the push side. So it's not on the pull mechanism. It's always based on the push. You fire and forget. You will not wait. You will not wait for the response. So it's a asynchronous always. Immediate action of the consumers. So and that's one of the key difference from if you go to the traditional queue systems, that and that's one of the key difference between the event driven architecture. Immediate action at the consumer level as well. So once you get the information, you start processing that event. Informational event as well. Someone has logged in, not command. So it's always an informational event. So it's not a command that you have to do something. So it's up to the consumer what they really want to do with that information. Pretty straightforward, right? So and let's look at the typical EDA architecture. So normally in any EDA system, you will have a producer, you will have a channel or the transport layer, and then you have a consumer layer. So in the event producer, you will have different systems who will who will produce the events that will go to a transport layer, and then systems who will consume those events, and then they can perform some operation. If we say what is really an event driven architecture in a definition, it's an architecture for a data in the application, which is really a modern design approach centered around the data that described or named as events. Examples of the events include the taking of a measurement, pressing of a button, or swiping of the credit card. All we can saw as an event. An event driven architecture enables application to act on these events as they occur, and this is the contrast to the traditional architecture, or maybe the SOA based architecture, which is largely dealt with the data as batches of the information to the inserted and updated at some defined interval, and responded to the user initiated request rather than the new information. And in event driven architecture, and that's quite an important thing, that event driven architecture creates, detect, consumes, and react to the events. Common concept in EDA or the event-driven architecture includes publisher, subscribe, source, and the sink. The publisher is the component that captures those event data, and stores into a repository. The subscriber then consumes and potentially responds to that event. Sources are where the data originate, and sink are destination where subscriber send the data. Yeah, and let's go in more in detail. So what is really the benefits? I mean, why we should use an EDA? I mean, it supports the business demand for the better service. No point-to-point integration. It's always fire and forget. It's fault tolerant, scalable systems, and we can also get loose coupling. It's really real time, and you can have a lot of analytics. And if you look at from the operational perspective, you can really get operational efficiencies. So we say it's asynchronous, we get loose coupling, we can easily scale our systems, and we can also have some sort of recovery support with, for example, an event-driven architecture with a queue can recover loss of work by replaying events from the past, because everything is logged and we can really replay the events, and this can be valuable to prevent the data loss when consumer need to recover. So definitely there are a lot of benefits with EDA, but EDA comes with price, and it also have some sort of a complexity, so we will talk about that. So I mean, if we go back and we say where we really come from, I mean, if we see from the time of mainframes, the big mainframe application, to the in early 2000s, we said we will try to move towards a SOA based architecture. Yeah, and then that's, so if you see even in 10 to 15 years ago, we will talk about always a monolithic application, where in Oracle world we do have an Oracle WebLogic servers, and we build either our SOA application, we use OSP, SOA suite, or any other middleware system, where we will have a one big jar or var file, where we have a lot of services as one jar or one var file, and where, for example, if in any company we have a different domain, like customer, inventory, payment, customer shops, customer orders, and so on, and everything is packaged into one big file, and you deploy into the application server. That's you call as an monolithic application. Might and it's an important point, because if you see in a customer or in the payment side, I mean these, because if you try to modernize this monolithic application to the microservices based architecture, you can really define these small part as a bounded context, or normally we also call as domain driven design. So customer can be a separate domain, payment can be a separate domain, and respective we can really segregate or categorize the services or the APIs respective to each domains, and that's why we normally call as the bounded context in the new world. Okay, so initially we started, we said, okay, let's try to implement service based architecture, where we build a service from shop to the customer, customer to the payment, reporting, and marketing. So we have a lot of point to point integration. Pretty easy. A lot of people start, I mean, got the real benefit, and then they said, yeah, it's good, we can really implement the service based architecture. But what is the real challenge here? Every time you need to connect. So imagine if we have a new here we have a new party which need to interact, we again need to rebuild again all this connection to different points, and that's why we call this point to point connections. And then we again evolve to new architecture, and we say, okay, we have a solution for that, and we will use ESP. And in Oracle world we say as Oracle Service Bus, we introduce ESP, and all these parties will always interact with the ESP. So we don't need to rebuild those services again. It will be reusable. We can have some sort of a governance in ESP, and the problem is solved. Is it? Let's see. I think it's a great improvement from point to point integration. I still see some of the enterprise still have point to point integration, so they still have to go far to ESP, to API driven architecture or the event driven architecture. So once we introduce the ESP, what's the next problem? Now imagine, let's add some fraud check as part of the shop, and let's add some new versions, because when you build a services you always have different versions. So in inventory we have V1, in customer we have new features, and we build a new service layer as V2. In payment we have some fraud check. Still it's manageable by the ESP. Let's add a new feature as loyalty features as part of here. So we have a new service, no problem. We're still able to manage to connect with the ESP and the integration still works. Oops, sorry. 1 second. I should run in the Power PPT mode. So we add the loyalty, and now if we try to scale up, and when we try to scale up, and we see the ripple effect of the integration, and that's what we call as, because imagine if another we have a lot of load on the loyalty, we have to another instance of the loyalty services, and then we still, it's hard to manage, right? Because loyalty might need to check the inventory, and then we have different versions, and there are a lot of challenges, and it's hard to manage or hard to do the integration. And if you see from the integration team perspective, there are a lot of challenges. They have to manage the versions, they have to add the new features, and so it's not easy. I mean, it's not easy to scale, because imagine if you have to loyalty is talking to the customer, and we have 5 versions of the customer service. But normally in ideal world, your enterprise should have some sort of versioning strategy. But even if you have a 3 version of the service APIs, and then you are confused, your developers are confused which service they need to talk with the loyalty service, and different versions, different connections, it's not scalable. Imagine now you have to scale the customer instance, and suddenly the load or the request to the customer services increase a lot, and you have to build 10 instances of customer service. How can you do that? It's not that easy straightforward. So what is the real problem? So SOA is all about the divided domain logic into the separate systems and exposing as a service. In some cases, the business logic will be by very nature spread out to many systems or across various domains, or the cross domains. You might have C on the underlying shop might have some sort of logic going to the inventory, and that's what we call as the cross domain. In the best practices, we should always avoid that, but in pragmatic or the real life scenarios, we always see these type of scenarios, and the result in the domain pollution. And so if we go across a lot of cross domain, then we will have some sort of a domain pollution, and that's we call then we corrupt our SOA system, and the advantage or the ROI we want to get with our SOA based architecture, we will not get exactly what we want. And that's how your architect, your integration team will look like. They all are frustrated how to manage. It's not that easy. Okay, let's try to find out some solution. Let's try to evolve more now. SOA and domain events. And when I say events, so if domains need to interact with each other, they rather than will talk by the SOA, they will talk by the events. So domain-driven design promotes the business logic to expose as a service, and focus should be only on that respective domain and the domain logic. They should not focus across the domain. Domain event is an activity happen in the domain expert is concerned. So always consult with that domain product owners who can define how that domain should be considered. And that's why we call. So if you have one domain where you build in some APIs on top of that, you always consider your API as a product, and you need to develop your product in that sense. And by exposing the relevant domain events on a shared event bus, we can isolate cross-cutting functionals to the separate system. So any cross-cutting or domains or cross-domain information should be part of as a separate system, and that's why you can secure your SOA system, or you can build a scalable or a robust loose coupled architecture. And then we introduce the event bus, which you say you still have, I mean, so if customer need to talk to the shop, they will always buy through the event bus. We still have the interaction via the event bus, OSP, or the event service bus, but then we will also using the event bus by which domains can interact with each other. And that's why once we integrate SOA with the domain events, and then how you can really scale up your services. So if you have to have another features, no problem, you just add that, because everything is not asynchronous. You don't make the point-to-point integration. You will just have a asynchronous communication. You just add the consumer, you just publish the events, and the interested consumers will consume via the event bus. And that's why you said SOA and EDA, you make me complete, and then they happily lived all after. Okay, before going to the event driven or the asynchronous in microservices, I will again want to go through the event driven architecture. So I would say event driven architecture is kind of an architecture where, or it's a model of the application design with event driven systems. The capture, communication, the processing, and the persistence of the events are the core strength of the solution. Nowadays, many modern applications design are the event-driven architecture. Event-driven apps can be created in any programming language because event-driven is a programming approach, not a language. Event-driven architecture enables minimal coupling, which makes a good option for the modern distributed application architecture. And EDA is loosely coupled because event producers don't know which event consumer are listening. So, for example, if I go back, so fraud don't need to know who are their real consumer. They just publish the events to the event bus, and depending, and if we have in now more new consumers, we can still consume by the event bus. So for the I mean, you as a producer, you don't need to know who's your consumer is, and you don't care about that. You will only care about your events. Yeah, and that's the advantage of EDA with SOA. Now coming back to this event driven, I mean I think nowadays there's a lot of buzzword happening is microservices, that everybody wants to implement microservices, and what exactly a microservices really is. So if we see, I mean if we took it the previous example where we do have a some sort of an e-commerce application where we do have different domains like shops, payments, customer, and we divided those monolithic application to the respective domains, or we build a microservices for each domain. So customer have their own microservices, payment have their own microservices, and shop have their own microservices. And if you say it has an API, it contains the logic, it will also have their own database and respective consumers, and then they all interact to the event hub. Event hub is nothing as service bus. So if we say enterprise service bus, which is a services interaction, a centralized bus into the enterprise. Similarly, event hub is a centralized system where all your events can interact with each other. So imagine once you build those microservices, payment services, customer microservices, they all talk to the event hub. Imagine now you have more channels or more producers of these events. You have social media, you have stocks, you have location, you have IoT devices, blockchain, mobile apps, and every these application can also pass a lot of streams of the event. It's hard to manage, right? And but how do you do that? I mean, if you see how you can really fit microservices and the event streaming process, and that's how you should build your architecture in your company or in the enterprise. So you have the microservices cluster which will pass the event streams to the event hub. You have different channels which also produce a lot of events. You will also pass through the event hub, and then once you have set up your event hub, you can also build your own cluster, but that's something more like into as part of the stream analytics. You can use your AI ML models to do the reference model. You can have the dashboard for good analytics, you can have the results, and then respective using the BI tools, you can have a good analytics. On top of that, you can build new search systems, because once you have some sort of events or data, and then you can have a lot of information you can dig in, and then you can also enable a lot of channels and so on. And that's why I've interacted. So you have consumers, or you have the producer of the event, you have microservices which will talk to the event hub, you will also have channels which will talk to the microservices, but it's always good to have an event hub which centralize, manage these events. And let's go into more into this domain event and the event sourcing. A domain event in domain driven design, domains are described that happens in something happens in the domain and is important to the domain experts. A user has registered, an order has been cancelled, the payment has been received. Domains even are relevant within a bounded context or across the bounded context for implementing processes with the domain. So if your enterprise are building a complex business processes which is relevant across the bounded context or a domain or within a domain boundaries, events are quite important. And event sourcing ensure that all the changes of your application state are stored as a sequence of event. So one of the difference between event and the event sourcing is events is just an information something has happened. So a user has been created and that's an event. When we say event sourcing is something which maintains the event state or the application state, and where you can really replay those events and stores the event that lead to the specific state and state to. So with the event sourcing you can really replay all the events that has happened. For example, if we look at the example here, that mobile number has been provided, verification code generated, mobile number validated, user detail provided. So if you go, eh, all these individual are as individual events, but if you combine these this is you call as an event sourcing, which you can also replay, and you can really find out what has really happened. These events are sufficient to reconstruct the current state of the user registration process agreed at any time. So you might have a business process which will say as a user registration, and if you want to really dig in or really want to understand what has really happened, if something is not really working, you can really replay and you can find out what is the problem, or how, if you want to optimize your business process as well. So if you say domain events best for communication between the bounded context. So whenever you have to interact between different domains, use domain events. If you want to have event sourcing, it's always good for the persistence strategy, because one of the key challenge with microservices or EDA is always the transition management or the persistence strategy. So event sourcing make it easier to fix those inconsistencies. Event sourcing is a local for each domain. So for each domain, you will have a local event sourcing, and so if it really help or make easy your life to do the persistent strategy. Okay, we have talked a lot about really about EDA, why EDA is good, why we should use EDA, how EDA should combine with SOA based architecture or ESP or OSP. So there are a lot of solution, and and a lot of people always say always Kafka is the best, and why Kafka is for event driven is the best solution. We will go into that. Kafka, and if you look at the diagram here, Kafka is really built a messaging system, a asynchronous messaging system, which enables to event driven architecture. So if you have a lot of producers of the events on the top, and then you have a lot of consumers, and then that's how you, and Kafka can be a good middle layer to pass that information. Kafka overview, if we what really Kafka is, so it's a distributed pub sub messaging system designed for processing of real-time activity stream data. For example, you have logs, you have metrics, collection, social media streams. Does not use GMS APIs in the standards, and that's one of the key difference. So if you are coming from the WebLogic background, and if you have used GMS, it doesn't follow exactly the same. So it's not follow those GMS concepts. Kafka maintains the feed of messages in the topic. So Kafka normally stores the message in the topic, which will go again in detail in the next slides. It's initially developed by in the LinkedIn, and now those teams have moved out from LinkedIn, and now it's part of the Apache, but the team have made another company or enterprise. Those group of people have made another company called Confluent, and they are still evolving Kafka or EDA based systems. So if we go to the Kafka history, Apache Kafka really started something around 2012, and then they built some new versions, and then in 2015 those team move out from the LinkedIn, and they have introduced a new company called Confluent, and now they have something called Connect APIs, which is they are start building the connectors to integrate with different systems. In mid 2017 they have introduced something called data processing stream APIs, and they're still evolving. I think this slide is not updated, but they're still updating the connectors and so on. And now Kafka, you can really say as this is a streaming platform. So not only for event sourcing, but also for the event streaming. It's also the best platform they try to build. Benefit of the Kafka, why we should use, so it's reliable, it's a distributed, partition, replicated, and the fault tolerant. Kafka replicates the data into replica, and because they always store their data in replica, so even if you have the failover, you can still able to manage or recover your data. And it's able to support the multiple subscribers, so if you have the multiple consumers, Kafka can support that. And additionally, it automatically balances the consumer in the event of failure. It's quite scalable. It's a distributed system that really can scale quickly. Durability, Kafka use a distributed commit log, which means message persist on disk as fast as possible, providing intra-cluster replication. Hence, it's quite durable. A lot of big enterprises already use Kafka. Performance-wise, Kafka has really a high throughput for both publishing and subscribing messages, and it maintains the stable performance even when dealing with the many terabytes of stored messages. And we have seen a lot of examples already in the market which already use Kafka with the terabyte of data. So what is Kafka? So Kafka, as we already said, it's a messaging system that is fast, scalable, and durable. The key concept of a Kafka, we always have a producer, we have consumers, and this Kafka layer, which is cluster, is a group of brokers which pass the information from producer to the consumer. The broker is mainly responsible for data when producer publishes. So it receives the data and is stored and is passed through the consumers. And consumer will then consume the data from the broker at the specified offset. So they always store in part of the they store the data as part of the broker into the specific offset, and respective consumer will read from that. A topic is category or the feed name to which records are stored and published. So for example, you have customer domain and you want to say customer address is changed, and that's and customer you can build as a topic. And if customer address detail is changed, that's an event. So you can store that event into the customer topic. Topic had partitions and order guaranteed per partitions. All Kafka records are organized into the topics, and producer application write data to the topics, and consumer application reads from the topic. Well, what are the key use cases why you should use Kafka? And because there are a lot of questions still raises in the enterprise, we still use JMS, should we still go for Kafka, or JMS still make a sense? That really depend on the use case, but on that perspective, if if you have key requirement, for example like messaging, where you have really high throughput and you really follow the microservices based architecture, you really have to develop the application loosely coupled, highly scalable, I think Kafka would make more sense. But you if from my side, if you're still into the WebLogic world or SOA, and you still not going across the domains and you still working on individual domain or the boundaries of the domain, I think JMS you can still use. But talking about the use case of the Kafka, messaging metrics, you want to track the activities of the websites. You have a lot of log aggregation with Logstash, stream processing, event sourcing, and the commit log. These are the typical use case of the Kafka. Kafka architecture, as I already mentioned, we have producers which produce the events. We have the consumers. We have a broker which is set of topics. So we have topics, and topic is always divided into the partitions. Different partition. Each topic will have the different partition. The data will be stored in the partitions in a different offset, and the consumer will read the data from respective offsets and so on. And that's a typical pretty straightforward in simple language, that's a simple layout for the Kafka. Normally how you manage the failover, the replica, that is managed something by the Zookeeper, which I haven't added here, but yeah, that's how they internally they manage the replica, the leaders, and so on, where you have the failover or fault tolerant data stored in Kafka. Key concept of the Kafka, topic is always divided into the partitions. The message order is only guaranteed inside a partition. consumer offset are persisted by the Kafka with commit or auto commit mechanism. So you can really configure that. Consumers subscribe to the topics. Consumers with different group ID receive all the message to the topic they describe. They consume the message at their own speed. So each consumer will have they will get the respective group IDs, and then with those respective group IDs you can consume that data. Consumers sharing the same group ID will be assigned to one or more partition of the topic they subscribe. They only receive message from their partition. So a constraint appears here. The number of partition in a topic gives the maximum number of the parallel consumer, and that's the important point here. So if you have the number of partition in a topic, that's the maximum number of parallel consumer you can have. So configuration of this thing is quite important, and that we should always keep in mind. The assignment of the partition to a consumer can be automatic and performed by the Kafka through Zookeeper, which I already mentioned. If a consumer stops polling or is too slow, a process called rebalancing is performed, and the partition are reassigned to the different consumers. So if one of the consumer is not able to pick the data, some reconfiguration or the rebalancing would happen, and that group ID will be reassigned to a different consumer who is more interested there. Key concept of the Kafka. So Kafka normally divides the topic into the multiple partitions. Each partition is an ordered immutable sequence of the messages that continue appended to. It follows the FIFO mechanism, first in, first out. When topic is created, the number of partitions should be given. So you need to configure the number of partition before. The producer can choose which partition will get the message, and or let Kafka decide for him internally. They can manage that. They use hash on the message keys, and the consumer will be assigned to one or more several partitions, and that's what we call as group. So if we say as topic as, I mean, because if we go really as topic, so topic is nothing, is just a category of the feed name which records are stored and are published. Kafka records are organized into the topics. Producer application write data to the topics, and consumer application read from the topic. Kafka retain records in the log, making the consumer responsible for tracking the position in the log. So it's the responsibility of the consumer to track the position by which they are reading. So, and that's what we call as offset. Typically, a consumer advances the offset in a linear manner as message and are read. However, the position is actually controlled by the consumer, which can consume messages any order. For example, a consumer can reset to an older offset when reprocessing a record. And in the topic partition, topics are divided into the number of partition which contain the record in unchangeable sequence. Each record is partitioned, is assigned and identified by its unique offset. And that's the important point here, because a topic can also have multiple partition log, and this allow multiple consumer to read from a topic as parallel. The partition allow topic to be parallelized by simply splitting the data into the particular topic across multiple brokers. In Kafka, replication is implemented at the partition level. So in each partition, we do have a replication, and the redundant unit of topic pattern is called as replica. Each partition usually has one or more replica, meaning the partition contain messages that are replicated over a few Kafka broker in the cluster. And that's, so normally, I mean, as we already discussed that, so the data stored in the offset, and consumer need to maintain the offset by which they are reading the data. That's a typically record flow which is happening in the Kafka. So there's a topic, we have the partitions, data stored in the respective offsets, and then you can have the parallel consumers to the respective group IDs. So as we mentioned, so if the record is already added to the partition world, then I mean partition 0, then at the offset 1, and the next record will be offset and 2, and so on. This is there will be always a commit log, so each record is appended to the log, and there's no way to change the existing record. So this is immutable. So something has already happened, you cannot really change. And this is also the same offset that consumer used to specify where to start the reading. I think we have gone through, so I will skip this slide as of now, just looking at the time. This is again an important topic here. So each broker holds the number of partitions, and each partition can be either leader or the replica of the topic. So all the red ones are the leaders and the blue ones are the replicas. So for this partition, this is the leader and these are the replicas. And all write and read to a topic go through the leader, and the leaders will coordinate to the different replicas with the new data. If leader fails, a replica takes over the. So if this is a leader, it will coordinate with the respective replicas, and by any mean, if this would fail, so we will have a replica would become the new leader. Normally, or you can configure that how many how many replicas you can configure, and that's part of the configuration of the Kafka. So producer write to the single leader, it will replica write to the different replicas. In the image, the producer is writing to the partition 0 to the topic, and partition 0 replicates that write to the available replica. So these are the two replicas. And normally, how many replicas we should have, that's what we call as the replication factors. So if we have this leader, it have the replica, and so here we have one leader, one replica. In this situation, we have one leader and two replicas, and that's what we call as the replication factors. This is the flow of the record in a Kafka. So it's produce, it's follow the first in, first out, and internally they manage the offset, and consumer need to maintain the logs by which they are reading it. Cluster is a group of broker working together, and broker management is done by normally Zookeeper, which is a separate component here. We have talked about a lot about the event-driven architecture, also about the Kafka. But imagine you are a big company like Netflix, Uber, and so on. You cannot, you can really set up your own Kafka as well. But nowadays, a lot of big enterprise where they really don't want to invest too much time or the energy or the budget into to set up all this by themselves. So nowadays, there are a lot of platforms coming as an event hub, and some of the key requirements as part of the event hubs are these. So we need to have, and these are the capabilities of the event hub which normally most of the organization require. I will not read all of them, but you can go through it, and this we really need to manage. We also need to have a good governance across the event management system, because tomorrow we can track. We also need to manage the whole life cycle of event across the organization. There are some of the alternatives or the alternative platforms we have on the Kafka. These are, ignore those. They are the typical message broker. These are not really the event-driven system like ActiveMQ, Rabbit, or the WebLogic. But if you see below one, these are all the event hub systems. Like in AWS, we have Kinesis. In Oracle side, we do have something called Event Hub Cloud Service, which is now depreciated, and now we have OCI streaming. Oracle Advanced Queuing is also not typical event driven, but we have Azure Event Hub, and we have a lot of Apache Kafka as a service from Cloud Kafka, and so many solutions. Confluent is still the major solution in the market. Yeah, so please have a look into that if you really want to dig into, or if you really want to find out the system of the Event Hub. We have talked about, so we have built, we have evolved from the SOA systems. Now we have implemented EDA, but what about the legacy system? We still have a lot of systems which is running on Oracle Forms. What about that? How we can really integrate those systems into EDA? So we have existing app which might be an Oracle Forms application. Typical scenario in most of the organization. Now we have the Event Hub, and if you want to make sure, if you want to pass some changes from a legacy app to the Event Hub, how can we do that? So we have a new app, which can be microservices. So Event Hub is talking to that, which we have already talked about. But if you have to integrate with existing legacy application, we can use Change CDC, the change data capture. That's a standard, and I think Oracle also supports that. And there are some of the CDC tools like Golden Gate for from Oracle stack. We have IBM and a lot of other tools where you can really do the CDC and integrate with the Event Hub. And if you see the complete picture, so initially we have the microservices, then we have some of the event streaming platforms, and now we have the legacy application which all talk to the event hub, and how you can then how that's how exactly your intuition would look like across your organization. You can also have your big data system where you can build your data lake and so on. So that's a separate thing. I will not go through in this session. Kafka ecosystem and Uber. I mean, if we just want to make sure how Uber have done it, so Uber also try to follow the same thing. So they have a lot of data producers. They have Kafka. They have some search, Storm, some other things exactly which we have done, and it's quite matching the architecture look like for normally in most of the organization. Integrate Kafka with legacy. I mean, as I already mentioned, Confluent have produced something called Kafka Connect, which they already built some connectors by which you can connect with the data source and the data sink. I will speed up a little bit as looking at the time. So Kafka Connect have built some connectors to connect with the producer and the consumers. So have a look, go to the Confluent site and check these connectors. So by which you can really connect to the producer as well as the consumers. And last thing I really want to talk, because I think most of the people already know now, if you want to manage an API lifecycle, we use API management tool. But what about the events? If you want to manage the lifecycle of an event, we have API management for tools for the APIs. So now there's another initiative going on right now, called something called async APIs, which manage the lifecycle for the events. And async APIs is the definition. It's the event definition. Similarly, as API definition, we have Open API or API Blueprint or the Swagger we call as. So async APIs define the definition for the event. So if you really want to start with events in your organization, have a look async APIs, and you can also start building your API definition. And so it's mainly used for the event management. And that's how because if you have already used API or Swagger, that's how some of the definition of your API, and it follows a similar pattern by which you can really define your definition of the APIs. Some of the I just for the information I put Open API specification, and this is the async API specification look like. Summary. If I want to summarize, always if you are into the monolithic application, make the split right, define your bounded context or the domain correctly, talk with the business people, and make sure you define your domains very correctly or the bounded context very correctly. Events, and also find out your right events for that respective bounded context. Events are the communication between the bounded contexts. Event can be async communication between the microservices. Kafka is a great source for the great tool for the messaging. Event Hub is a key in a new enterprise integration world. So if you are an integration architect or integration manager, you cannot ignore Event Hub, especially in the cloud native application. Use CDC to integrate with the legacy integration, and have a look into the async APIs. It's open source, and yeah, you can also contribute if you want. These are some of the references which you can have look. Unfortunately, this is a pre-recorded session, so I cannot have the live session because my time is not matching with the scheduled time with the conference. But if you do have any questions, please write it to me. You can connect with me via LinkedIn or the Twitter. I would be happy to help you. That's all. Thank you very much, and be safe.